guys have all worked probability before. There's a good chance that you might remember it. So probability. Probability is written like this. Probability of some event occurring. Excuse me. What you're looking at here is something very, very simple. Favorable outcomes over total possible outcomes. In other words, what you want over the total amount possible. So the probability of picking a card, we're going to kind of do this for Melms? Wrong, but you know, it's nice. The probability that she could pick the right card, where she said, hey, I want the probability of the 3 of diamonds. Okay, that's the event. How many ways can that occur in one deck of cards? 1 out of how many? 2. There you go.
We're just in the back.
What do you guys do?
MVP.
Do you have a platform or something?
You say?
Wait, come here.
She get a play?
Yeah. It's me or Kevin.
Maybe a junior next year.
Oh, definitely you.
Wait, Gabby,
I would tear him.
I think he's running for both.
Really?
I think so.
I signed one for him and it was president.
Really?
Sorry.
Yeah.
Vote for me because you have no choice.
So, the probability of events occurring is what you want over total possible. I know that most of you guys have all done this before. Do you guys know that there is a range within probability?
No, I did not.
So probabilities of some event is always going to be less than or equal to 1 or greater or equal to 0. Okay? The probability, if the probability is 0, not going to happen. Bless you. The probability of an event,
Is that gun?
I don't know. If it's 1, I think it's Geo.
Ghana.
Yeah.
Ghana.
If the probability of some event happening is 1, it's gonna happen.
Yeah, probably. At some point.
For example, the probability of homework. Oh. See what I did there? That's a completely irrelevant idea. How many doubles teams are going to state? 64. So you have a 1 in 64 chance of winning it all.
You can't. I don't know. I don't like. Can you do that with sports based on like how good the team is?
And then you're looking into weighing in factors, and that's where odds and stuff come into play. Okay, that's when you start looking at that kind of stuff. Pure probability is favorable over total possible. You're looking at multipliers that we don't really get into. That's more a Vegas thing. Okay. So yeah, that's easy. We're bringing in the devil now. We're rolling a 6-sided die, so we're rolling dice. Not only are we rolling dice, we're playing cards. And they're numbered 1 through 6. I'm actually impressed that this book calls it a die instead of a number cube. So a lot of times we'll call it a number cube because dice implies gambling. Number cubes just imply number cubes. So if I want to take what is the probability that we're going to roll a 4?
Darn it.
What is the probability I'm going to roll an odd number?
3 to 6.
3 out of 6, otherwise known as half.
Wait, it's 1 on.
How about that storm last night? Yeah, we're gonna by 11 o'clock.
It wasn't odd.
All right, see if you get an odd number. Yes! What about rolling less than a 7?
100%. 100%. Unless if you're rolling 2.
1.
Let's not get into that.
Okay. Sometimes you talk about what's called an experimental probability versus theoretical probability. It's probabilities that you see in real life. So I've been running, you know how I've been looking at our Powerball thing?
Did you win yet?
No, I won the $1 million twice, but the differences that you're seeing here is that you've got the odds. It's kind of like the probability of getting one of these numbers right off the draw, because there's 55, it's 1 out of 55. Over the course of time, in 45,000 years, my model that I'm doing here, I've won, and on average, 1 out of 58 times. So my experimental probability is a little bit different than the theoretical probability. Yes, sir?
So the theoretical probability is
Pure, yes, it's the pure math. It's like flipping a coin.
Like what
You can flip
should
a coin.
happen?
Yeah, you can flip a coin 10 times and you could get 8 tails and 2 heads.
then the experimental is what actually happens.
Correct. All right, and that's where you get into it. And then we've done this before when we had a little bit more time, where we've done the whole flip the coin thing, and everybody did it like 100 times, and we tried to pool all of our data together. You can see that theoretically it should be half and half, but yet it's not. And it's not because there's more rain on one side than the other. No, it's just because you flip a coin and that's what happens. So that's kind of what we're looking at. But a lot of times we'll also look at some data stuff. And this is actually really, really, really easy. When we have a data set, and I don't want you guys to write all this out, I'll just walk you through how it sets up. You're going to ask, for example, the person is at least 45 years old. Now, you're looking at people that are 24 and under, 24 to 44, 25 to 44, 45 to 64, 65 and older. If I'm looking for just people that are 45 years at least, which one am I going? Above it or below it? Above it. So what I would be doing in a data set like this, I'm trying to count everybody to the right. I'd add those two numbers up and I would divide it by what? How many people are there? That's what I'm doing. I'm looking at a data set and answering the question. So I'd add up 55, 446, 34, 076 and divide it by 94, 507, 83, 608, 55, and so on and so forth. And that's what I'm looking at for.
Divided by those or by 4?
By those, because these are the total number of people, is this. Favorable outcome over total outcome. You're just looking at a chart to get that information.
Okay.
You're just looking at a chart to get the information instead. You might have done this in some sort of a science class or something like that when you're trying to do data testing or something. It sounds like something you would
like
do.
natural selection and stuff like that.
Yeah. So that's this part. Meh. Meh. That's pretty quick. Geometric probability. Remember this?
No.
Geometric probability is favorable area over total area. There's a lot of little things you could do here. Let's say I want to get the bullseye. How do you find, I'm assuming you guys understand that it is a circle, right?
Yes.
Okay. So if that's a circle, how do you find the area of said circle?
Pi times something.
Pi r something?
That's where it is.
It's pi r squared.
Something.
So if 3 is the radius, what's the area? Yes. 9. Thank you. 9 pi. What is the radius of the largest circle? We're going to get you the noggin. 12. So what is the area of the total circle? 144 pi. So
Pi.
so if my favorable region is 9 pi, and my other one is 144 pi, what's the probability of landing in the bullseye?
Apple.
Apple. Be careful, if you use just the division button, you have to throw parentheses around the 144 pi, or just realize that the pi is wrong. Otherwise, use fraction.
60.
Ooh, nope. Not calling it?
Yeah.
What if like an administration person came in?
They'd say that's pretty damn awesome, or if you keep it up.
That means we do it again. We all get a shot?
No, I don't trust you with this.
I don't blame you.
I'm like Romeo. Oh, Romeo, or Julia, I don't know. No,
Robin. Robin?
yeah, Cupid, that's who it is.
Where do you know?
Actually, I'm Marquis. I know. No, look.
That was actually close. That was better than you looked.
It's better than you look.
Oh! Dude, he
I'm
just
really
called you
upset
a
my
two.
sound's not working.
He just called you a two. Rose, just to let you know.
I hit sound, I don't know what the sound is.
Ooh, roasted.
What? You're really nervous, aren't you? I don't blame you. But you crossed over.
You can see the shot.
Yes, my bow and arrow is defective.
Operator.
How many times did the shot?
Oh, way too many.
Have you ever done rumbles?
Yeah, yeah.
Really?
Oh.
Sassy McSasserson today.
Let's see if you can delete it.
Oh, that's
Hey!
funny. Why isn't my sound working?
What is this supposed to do?
It's supposed to make sound effects when I hit the board. They're upset.
Turn it up.
I think the
I am the champion. I am the champion. No time for losing, 'cause I am the champion of the world.
wow.
Uh-huh.
What?
I'm done. I'm quitting now.
Got it!
So, like I said, I'm the best shot ever.
Well, why didn't they make this up?
I don't know.
I am the champion. I am the champion.
I'll tell you
No
why.
time for losing, 'cause I am the champion of the world.
They want Cole's pictures.
The reason why it doesn't play right off the bat, the old style smart boards. I've been using this picture for geometry probability hasn't changed in I don't know ever. So I've saved this slide for ever, and I used it when we used to have the old style smart boards. The old style smart boards, if you take your thumb and you push against it a little bit here, there's a little bit of a pressure to it. So if you make it a little bit more of a fist, so it's a little bit tighter, you can still push against it. There's a pressure part to it. The old boards had pressure plates, had a little pressure to it. So when you touched it, that's where it knew where you were. So as soon as this thing hit the board, it would go off right away. The newer ones have cameras in the corners. There's no pressure point here. It's a solid board.
Whoa, whoa.
That was weird. It won't happen anymore. But now that there's cameras that sync where things are at, so it just doesn't pick up the what do you call these, bow and arrow, or the arrows as well as, sometimes it works, sometimes it doesn't. So, but geometric probability, favorable over total.
Do the other ones look the same?
They do.
Can we listen to them all?
In case I missed the bullseye, it boos me. Oh yeah, I'm all full of stuff here. How do you not like yakety sax? Loser.
What is that?
I don't know. Anyway,
Heard before.
That's from cartoon.
it is. Same idea. Oh, we just did this, and that's boring. Do you remember how to do this?
They like subtract the shape from it.
Yeah.
What is the shape on the interior? I know you guys are getting all the heebie-jeebies right about now.
Hexagon.
It's a hexagon. When you have a regular hexagon or a regular polygon inscribed in a circle, that means you have the area is called 1/2 perimeter apothem. Vaguely remember that?
No. For what good reason?
Oh no.
1/2 perimeter apothem is how you find the area of a regular polygon. In this case here, there is a really, really nice way of doing this. This is how I always show these. No matter what, an apothem is the perpendicular bisector of a side of a regular polygon. It is from the center. The center of the polygon is also the center of a circle. Therefore, it creates a radius from the center to a vertex. That radius, if you recall, bisects that interior angle as well. So what I always do with these things, whether it's a hexagon, heptagon, dodecagon, whatever, is I always start on the outside angle in. How many degrees are going around at any figure?
360.
How many angles are there? What's 360 divided by 6?
Oh.
60.
60. Which means the interior is 120, which means when it's bisected, it is 60. The side lengths were 16, which means these are 8 and 8. So what is my apothem if across from my 30 is 8? It's a 30, 60, 90. So it is 8√3. And my radius is also 16. Because I want to land in the shaded region. So the probability of the shaded region here is going to be the area of the circle, 16 squared pi, subtract out the hexagon, the 1/2 perimeter, 6 sides of 16, times my apothem of 8√3, all over, what's the total? Is it apothem or apothem?
All of last year I pronounced it apothem.
Sure. It's a both time. You pronounce it right. That was Canadian, right?
What time, eh? Sounds like you
I'm
should
actually
have
Canadian, Mr. Murphy.
What's that?
I'm actually Canadian.
Oh, you betcha.
Yeah, you're such a holder, eh?
Oh, yeah. Take off, eh?
Importance.
So basically what happens here, you just gotta be really careful when you put in the calculator. When you put in there, use a fraction bar, type it all through. Otherwise, you'll get an answer that's greater than 1 or less than 0. Well, you can't get less than 0. If you really get like a negative number, you really, really messed up. Yes, sir. It's the area of the circle. Subtract the hexagon. Because the area, the circle here had a radius also of 16. And this is just the whole, that's when we do this, there are 6 sides of 16. That gets me my perimeter. And the apothem is the 8√3 because it was a 30, 60, 90. Yes, ma'am.
So then the calculator, we're going to get decimal.
Yep.
So it's okay.
Yeah, well, yeah, you're going to get a weird decimal because it's going to be less than 1. That's how these work. Okay. We'll spend a little bit more time on this stuff probably later, but I think I'm running out of time.
Yeah,
already.
4 minutes.
4 minutes. All right, sweet.
What's on the move, bro?
I don't know if we're going to get to this. We might not get to this with the combinations. So, all right. Let me give you some 12-3 to work on.
Thank you.
You know what I have written down on my phone?
Amount of pages.
Why do you keep ripping holes off?
Was it moles?
No, it's not a real mole.
I did, so okay. Risky. You know the brown thing?
Would you do that to another face?
through.
Relative 13. Mr. Murphy.
Yeah, ma'am. Yes, ma'am.
Never
Bye-bye.
mind, never mind.
Do those, they're quite literally
Does that say and 41?
draw a heart, roll a die. There's one geometric probability with a couple of parts, so it's just dealing with circles really. And then we'll talk a little bit about permutation combination style with these. I don't know if we're gonna get too crazy with that, because I just don't think we have time. So I just want to do compound events, independent, dependent, binomials. I don't know. That stinks. All right, we'll go from there. All right, what's it gonna be? What do you got?
Want to play? Alright, ready?
Yeah, well. Give a rectangle. You want to roll. See you guys.
Category is?
Go.